This lecture is on our very own Milky Way Galaxy. The Milky Way is a flattened disk with a big bulge in the center, and if we look through the disk, we'll see a lot more stars than if we were to look above or below the disk. In the late 1700s, Sir William Herschel figured that the Milky Way Galaxy was 5 times wider than it was thick. If the Milky Way were spherical, we would see a uniform sky with stars evenly spread out in all directions. However, we don't see this. When we look up in the night sky on a very clear night, and we would see a band of stars. It looks like spilled milk on the night sky, which is how the Milky Way Galaxy got its name. Galax means milky. United States astronomer Harlow Shapley determined that the Milky Way's diameter was about 3 times too large. In reality, the Milky Way's diameter is closer to 33 to 35 kiloparsecs, which is about 100,000 light years. Modern-day astronomers conclude that our own Milky Way galaxy is very similar to this galaxy. This galaxy has a bright center and spiral arms that come out, and is called a spiral galaxy. Typical spiral galaxies are made up of a disk with the arms, with a diameter of about 25 kiloparsecs, or 80,000 light years. It's surrounded by a halo, and it has a big bulge in the center. So your big bulge is here in the center. These are the disks, or otherwise known as the arms. And our solar system is about halfway through one of those disks or arms. From a side view, you'll see the bulge in the center. The flattened arms are disks, and then surrounding that is the halo. Beyond that, there's a lot of research now going into looking at the dark matter halo. Spiral arms are within the disk, and they move from the center and spiral outwards away from the big bulge in the center. Our solar system lies about 8.5 kiloparsecs, or 28,000 light years from the center. Huge clouds of gas and dust amount to about 15% of the entire galaxy's mass. This 15% of dust will dim the light of many stars and hide the nucleus of the galaxy from us. The nucleus is a dense swarm of stars and gas, in which perhaps massive black holes lies. Recently, astronomers have detected a supermassive black hole in almost every galaxy they look at. We can, quote-unquote, see the nucleus only with radio and infrared telescopes. Here, this is showing you that our sun is here, and these gas clouds are surrounding our nucleus, blocking the nucleus from our view. Radio telescopes reveal that gas lies in the outer parts of the galaxy, out nearly about 40 kiloparsecs, which is about 130,000 light years. Remember, we're at about 8.5 parsecs. Astronomers also believe that the galaxy may contain an unobservable dark matter that may extend farther yet. This is an area of a lot of intensive research right now. The flattened shape of the disk suggests that the Milky Way will also rotate. The Sun and neighboring stars move around the Milky Way galaxy with a speed of about 220 kilometers per second. Let that sink in, 220 kilometers every single second. The disk makes one complete rotation approximately every 240 million years. So the Earth went around the center of the galaxy about 20 times in its lifespan. The Sun and other stars orbit the galaxy's center due to gravitational attraction, much like the planets and how they orbit our Sun. All stars orbit in the same direction in nearly circular orbits around the center of the galaxy. Stars near the center of the orbit travel faster than the stars further out. This is very similar to our own solar system and how the inner planets travel faster than the outer planets. This differential rotation plays an important role in making the galaxy's spiral arms, because the parts of the stars closest to the center are going to orbit faster and essentially get ahead of the ones behind it, and that causes it to spiral out and behind. In our part of the galaxy, stars are widely separated. The Sun's nearest neighbor, which is Proxima Centauri, is 4.3 light years away. Near the Milky Way's core, the stars are about 1,500 times closer together than they are near the Sun. The density of the stars near the core is probably more than 10 million stars per cubic light year. Near our sun, the star density is only about 0.003 stars per cubic light year. Farther out, the density of the stars is even lower. There is no defined edge to our galaxy. It just continues to slowly dissipate. Astronomers have estimated the mass of our galaxy from its rotation. On the basis of the gravitational attraction needed to hold the sun in orbit, the galaxy must contain about 1,011 solar masses of the stars and gases. This is much like calculating the gravity of the sun based off of how the planets revolve around the sun. The gravitational effects of the Milky Way on other galaxies imply a greater mass of about 5 to the times 10 to the 11th solar masses. If we assume that the majority of the stars have a mass of about equal to that of our own sun, the galaxy may contain as many as 100 billion stars. Astronomers calculate that the oldest stars in our galaxy are about 13 billion years old. Can you remember how old our galaxy is? Our galaxy is 13.82 billion years old. During this time, most of the original gas that has been converted into stars. Eventually, in about 10 billion years, the Milky Way will lack the material to make new stars and will begin to dim and the light will go out. The Milky Way contains all the types of stars that we have talked about with stellar evolution. Astronomers can deduce some of the history of our galaxy by analyzing the types of stars and their relative numbers to each other. An important statistic that comes from a stellar census is the number of stars of each mass. This is known as the mass function. The mass function can help the astronomers estimate the lifetime of the galaxy and its luminosity. The greater the number of the high-mass stars, the brighter the galaxy will be, and the shorter its lifetime. Studies of the mass function show that the stars similar to or smaller than our sun make up the vast majority of the stars in our Milky Way. Dim, cool red dwarfs make up the most number of our. These stars are a type of main sequence and have a mass between 0.1 and 0.5 solar masses, so that's 1/10 to the half the size of our own sun. The average mass of these stars in the Milky Way is about 1 solar mass. All the stars in our Milky Way can be placed into two main groups. Population 1 stars are blue stars in the disk of the Milky Way, whereas population 2 stars are red stars located in the bulge of our galaxy. The two populations will be referred to as Pop 1 and Pop 2. These two populations of stars differ in almost every aspect. They differ in terms of color, age, location in the galaxy, motion, and composition. Population 1 stars are very young, typically a million to a few billion years old, and many are blue. They are typically located in the disk and follow the approximately circular orbits. Population 1 stars are composed of mostly hydrogen and helium, much like our sun is. About 3% of their mass is in heavy elements such as carbon and iron. Population 2 stars are generally red and old, usually about 10 billion years old or older, and they are in the bulge and halo, moving along highly elliptical orbits. Many orbits of the population 2 stars are tilted strongly relative to the disk. Only a few hundredths of a percent of their composition are heavy elements. A number of stars, including the sun, do not necessarily fit this classification scheme exactly. Because they don't all fit exactly, each population is divided into extreme and intermediate subcategories. This is our center bulge in the galaxy, and population 1 stars are going to orbit in the disk. Again, reference, this is our center bulge, this is our disk. Population 2 stars, you'll notice, are very elliptical and tilted. Some of the galaxy's stars are bound gravitationally into groups called star clusters. So this is a clump of stars that move together. There are two main types of star clusters. We have open clusters and globular clusters. Open clusters have up to a few hundred stars in volume of a radius of 7 to 20 light years. This is an image of an open cluster. Note the space between the different stars. They are still clustered together, but there is some space in between them. Pleiades is another example of an open cluster. Again, you can see they're relatively close, but there is some space in between. Open clusters may form when a giant, cold interstellar gas cloud moves into one of the galaxy's spiral arms. The stronger gravity within the arm compresses the cloud, which collapses to form hundreds of stars. These stars are gravitationally bound to each other. Over time, hundreds of millions of years, stars gradually escape the cluster, and the cluster dissolves. It is estimated that there are about 20,000 open clusters in the Milky Way Galaxy. A globular cluster can contain a few hundred thousands to several million stars. Globular clusters are larger than open clusters, having a radii from about 40 to 160 light years. The large number of stars creates a stronger gravitational pulls of the stars, and that compacts them into a tighter ball. Note the high density in the center, and it's fairly circular or spherical. An estimated 150 to 200 globular clusters orbit the Milky Way. Population 1 stars tend to contain open clusters, whereas population 2 stars tend to contain globular clusters.